Welcome to Patrick Talks Teaching. Today's topic in the world of math is none other than trigonometry. Trigonometry has three root words: tri, meaning three, gono, meaning angle, and metri, meaning measure. So we're talking about triangles with three angles, three sides. And we need to analyze this triangle thoroughly in order to understand what's going on. So let's start with some properties that we have going on in this triangle here. First off, of course we have right angle triangles. And that can be noted by the little box that's in the corner here. This represents a 90-degree angle. Now, if we choose an angle to consider like this one right here in the bottom corner, we're going to mark it by a theta, which is a Greek letter that represents angle. Now, this angle is made up of two sides. One side's called the hypotenuse. That's the longest side of the triangle. It's also made up of another side on the bottom here, which I'm going to highlight, and that one is called the adjacent. Now, there's also one other side to this triangle, which is far away from our angle of interest, and it's called the opposite. You'll notice it's the only side that doesn't touch the angle of interest. These three sides can help us analyze relationships within the triangle, and there are three ways we can do this. One is called sine, another one is called cosine, and a third one is called tangent. Now, each of these represents a ratio of two sides of the triangle. Sine represents opposite divided by hypotenuse, cosine adjacent divided by hypotenuse, and tangent is opposite divided by adjacent. To understand what these mean, I like to think of analogies, and I got a pretty good one for this. I have to tell my students, imagine that you're going on vacation to a country where you don't speak the language, and you're going to need an interpreter. When it comes to travel and tourism, I'm going to use the sine interpreter. When it comes to food and restaurants, I'm going to use the cosine interpreter. And when it's a question to do with the hotel, I'm going to use the tangent interpreter. Depending on what I need, I'm going to seek out a specific interpreter. When it comes to triangles, the same holds true. Depending on the information that I have in the triangle, I'm going to have to resort to one of sine, cosine, or tangent. It just depends on what do I know and what do I need to know in the triangle. So now it's time to look at all of this in context. So here's an example problem. If we want to solve for this mystery side x on the bottom here, we're going to start with our angle, 20 degrees here. And remember that it's made up of two sides. This one, the longest side, is the hypotenuse, and the bottom one is the adjacent. And the side far away over here is the opposite. Once we've labeled all three sides, we have to figure out which of these three trigonometric functions, sine, cosine, or tangent, we're going to use to help solve our triangle. So notice that the sine function uses opposite and hypotenuse parts, cosine uses adjacent and hypotenuse parts, and tangent uses opposite and adjacent parts of the triangle. Sohcahtoa, a helpful tool. Here in our problem, we're given the hypotenuse, so I'm going to put a little check mark under the h's in the word Sohcahtoa. We also want to find the adjacent, so I'll put a question mark underneath the a's in Sohcahtoa. Notice that the opposite is completely irrelevant to our problem, so I'm going to cross out anything that involves the opposite. So guess what? The only thing that's going to help us is cosine. I could get rid of the other two. And now I could simply plug in my information into this equation. Remember that that little theta symbol represents our angle, and I know that, so I'm going to write down cosine of 20 degrees, which is equal to the adjacent, which is the part I want to find, so that's just the letter x, divided by the hypotenuse, which we know is 5. Algebra always tells us that we need to isolate our variable, the letter x. So since we're dividing by 5, I'll multiply by 5, and that'll cancel out. If I do it to one side, I have to do it to the other side as well. So all I have to do on my calculator is 5 times the cosine of 20. And what that gives me is the answer to my problem, which is 4.7 meters. Well, since the hypotenuse at 5 meters has to be the longest side, 4.7 makes sense. Here's another problem to take a look at. Remember the first step for every triangle, always label the sides. Longest is the hypotenuse. Also touching the angle there is the adjacent, and way far over here is the opposite. Let's write down that word, Sohcahtoa, once again, and see what information we have and what information we need. Well, let's start over here. We have the opposite, so again, I'll put a check mark under the O's in Sohcahtoa. We want to find the hypotenuse, so that means a question mark under the H's. Notice this time that the adjacent is completely irrelevant to our problem. We don't want it, and we don't have it. So I'll cross those out. That means sine is the function we're going to use. So let's plug this information into our equation. First off, the sine of our angle, we write down sine of 20 degrees, which is equal to the opposite, which is 6 meters, divided by the hypotenuse, which we don't know, so the letter x. Now a simple trick, if your unknown is in the bottom of the fraction here, just switch spots, and we could rewrite it as x equals 6 over sine of 20. You could go through the algebraic steps, but this is probably the easiest way to just do that. And our answer is going to be 17.5 meters. And again, this makes sense because the hypotenuse is always the longest side. Let's take a look at one last problem. Here it's the angle that's the mystery part of this question, the part we want to solve. So of course, let's label our sides. Here, touching the angle is the adjacent, and of course the hypotenuse, and the opposite is on the bottom far away. So we're going to use the cosine function, which is adjacent over hypotenuse. Now we could just solve this fraction, which is the same thing as 0.625. Now it's not the cos of our angle that we want the actual angle. So this is the time where you're going to have to do the second function, which is the inverse cosine of 0.625. And that's going to spit out an answer somewhere in between 0 and 90 degrees. And our answer here, 51.3 degrees, which is less than 90 degrees, so that makes sense. So to summarize trigonometry, a few things that you need to know. We're talking about right angle triangles, and we're going to use Sohcahtoa, sine, cosine, and tangent to solve everything we need. Well, thanks for listening. Till next time.